Hi, this is Miss Berenboom. We are looking at Learning Target 14B, which is going to look at scientific notation, and this is day 1 of 2. Okay, so let's start by just taking a quick look at what scientific notation is and how we might be able to use it.
Math Shorts. Scientific notation is a concise way to express very large numbers, such as the circumference of the Earth in centimeters, or very small numbers such as the diameter of an atom. Scientific notation is written as a product of a number and a power of 10. Here's a number in decimal notation. That's a small number. Time for scientific notation. First, move the decimal over until there's just one non-zero digit to the left of the decimal point. The exponent indicates how many places the decimal point has moved to the right. This is the same as saying 5 4/10 divided by 10, 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 divided by 10. Woo! A more concise way to show you're dividing 5 4/10 by 10 8 times is to say you're multiplying 5 4/10 by 10 to the power of -8. That's using scientific notation. The method is similar for numbers that are really big. To change from standard form to scientific notation, just keep track of the decimal. For whole numbers, the decimal point is at the end of the number. Move the decimal point so there's only one non-zero digit to the left of the decimal. The exponent indicates how many places the decimal point has moved to the left. That's the same as saying 4 75 10,000ths times 10 times 10 and so on, for a total of 9 times. Multiplying by 10 9 times is represented by the exponent, positive 9. Why do we need this number to be between 1 and 10? To make it easier to understand, compare, and do arithmetic with extreme numbers. To understand this number, you have to count up all the places to see if it goes to the millions, billions, or higher. In scientific notation, we can understand that the value of the number is approximately 4 with 9 zeros after it. At a glance, these two numbers look like they're almost the same. To know for sure, you can count the digits, or you can use scientific notation. We can see that the number on the right will be bigger, since it is multiplied by 10 to the power of 10, whereas the number on the left is multiplied by 10 to the power of 9.
Okay, so let's take a look at what we just learned. So we know that scientific notation is basically a way that we can rewrite really big or really small numbers to make them easy to compare to one another and do some basic calculations with. So if you're going to write a number in scientific notation, it has to consist of two parts. We need a number between 1 and 10 times a power of 10. So it's going to look something like this. So C, so representing some number, times 10 to the nth power, where again C has to be that number between 1 and 10, and N is going to be that exponent telling you how many times you move the decimal to make that value between 1 and 10. Okay, so let's take a look at a few values and just decide whether or not they're in scientific notation or not. So the first one, we've got 23.98393 times 10 to the 9th power. Now it's a number times a power of 10, which is good. However, when I look at that number in front, I have 2 digits to the left of the decimal. It is not a number between 1 and 10, so that first one would not be in scientific notation. The next one, we've got 4.1938 times 10 to the 4th. So I've got a value between 1 and 10, one non-zero digit to the left, times the power of 10. So yes, that second one is in scientific notation. The next one, we would have to say no, this is not in scientific notation because that number in front, again, is way too big. There are many non-zero digits to the left of the decimal. And then our last one here, this first part is good, 2.2221, so one non-zero digit to the left of the decimal. However, when I look after the multiplication sign, I don't have a power of 10, I have written times 10,000, and so to make it true scientific notation, you'd have to change that over to a power of 10. So no, this one is not in scientific notation. Okay, so let's talk about how we can change back, or change from standard form into scientific notation. So the first step is going to be to figure out where you want the decimal to be so that there is just that one non-zero digit to the left of the decimal point. You're going to count how many decimal places the decimal has moved from the original number. That's going to be your exponent. And we know that if the original number was less than 1, we'll be using a negative exponent. And so if it was really small, a negative number. And if that original number is greater than 1, so a really big number, then we're going to have a positive exponent. So for example, if I took this number and wanted to write it in scientific notation, the first thing I'm going to do is think about where do I want the decimal to be. Well, to have one non-zero digit to the left, I'm going to need it here between the 2 and the 8. So I'm going to count. The decimal right now is at the end of this number. So how many times do I have to move it to get it in between the 2 and the 8? Well, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to write this as 2.898 times 10 to the 8th power. And again, it's a positive exponent because it was a big number to start with. All right, example 2. Let's take this number and write it in scientific notation. Now this is a really tiny number. It's something less than 1. So that's indicating that we're going to have a negative exponent. But same process goes. We're going to figure out where we want the decimal to be and how many times we have to move it to get it there. So right now I want to get the decimal between the 5 and the 6 because that will give me one non-zero digit to the left of the decimal. So I'm going to move it 1, 2, 3, 4 times. So it becomes 5.67 times 10 to the negative 4th because again we're using a negative exponent because this was a tiny number, a tiny decimal. All right, the next one. Write 58,000 in scientific notation. Okay, so to get one non-zero digit to the left, I want the decimal in between the 5 and the 8. So I'm going to grab the decimal and move it 1, 2, 3, 4 times. So 5.8 times 10 to the 4th, and it's a positive exponent again because this was a big number to start with. Okay, so I'm going to have you guys write each of these in scientific notation, and then when you're done, you can check your answers. Okay, so let's look at the first one here. You should have rewritten that as 3.78 times 10 to the 5th. You'd have to move it 5 times to get it between the 3 and the 7. Okay, the next one, we're going to write that as 6.83 times 10 to the negative 5th. Negative exponent here because you'd have to move it back to the right to get it between the 6 and the 8, and it was a really tiny number to start with. And then our last one is going to become 1.7 times 10 to the 1st power. You only needed to move the decimal 1 time, and it's positive because our original number was something greater than 1. All right, so now let's look at how can we change from scientific notation back into standard form, so back to how we normally would write a number. Okay, you simply move the decimal point to the right when the 10 has a positive exponent, and you move the decimal point to the left when your power of 10 has a negative exponent. So the exponent will tell you how many times to move it and which direction. So if it's positive, we want a really big number. If it's a negative exponent, we want a really tiny number. And anytime you're moving the decimal and there's no values in that place value, we use zeros to fill in. Okay, so let's take this number and write it in standard form. Okay, my exponent here is positive 6. So that's telling me that I want to have a really big number, right? So I want to make this big, like probably in like the millions. And I need to move the decimal 6 times. So I'm going to grab the decimal, and to make it a big number, I'm going to have to move the decimal over to the right. So I'm going to move it 1, 2, 3 times around the 3 numbers that were there. And now I still have to move it 3 more times for a total of 6. And I'm going to be filling in with zeros in those empty spaces. So this is going to become 5,093,000. Okay, and then our next one, let's take this number and rewrite it in standard form. So I'm seeing a negative exponent here, so negative 4. So I'm going to move the decimal 4 times, and I want to make this a tiny number because I've got a negative exponent, which means I'm going to move the decimal farther back to the left. So I'm going to grab it and move it once around the 1, so that's 1 time, and then 2, 3, 4, so a total of 4 moves, and I'm going to have to fill in with 3 zeros here. So my number is going to get rewritten in standard form as 0.0001976. So I should have 3 zeros between the decimal and the 1. All right, so you guys are going to try these 3, and then you can check your answers when you're done. Okay, so let's take a look here. This first one, we had a positive exponent of 5, so we're going to move the decimal 5 places to the right and get an answer of 149,300. All right, our next one, we had an exponent of negative 7, so that means we're going to move the decimal 7 places to the left And so after your decimal point, you should have 6 zeros before the first 9. And then the last one, we had an exponent of 0, so that means we're moving the 0 or the decimal 0 places. And so it's really just 4.563. Another way you can think about it is that we know anything to the 0th power is equal to 1. So this number times 1 is just going to be itself. All right, so to wrap up, if you could record something you learned or were reminded of, and then a question you have, and that would be it for today. All right, thanks for watching.